Life. It's one of the most spectacular and rare occurrences in the universe. From a collection of inert molecules and compounds, an inanimate creature is born, capable of thought and self-preservation. Life is somehow ancient but always new, perpetually changing while preserving the past. And to our knowledge, life is only found on one rocky scrap of dust in a rather unimpressive galaxy. But here, on this lucky scrap of dust called Earth, life has taken over. 4.5 billion years ago, a cloud of debris surrounded a newborn star, our Sun. From this cloud, the planets formed, including the Earth. At first, it was an inferno of volcanism and perpetual tumult. But soon, the Earth cooled, and due to a volcanic process known as outgassing, a dense atmosphere developed shortly after. And as the surface cooled further, liquid water began to pool, first into springs, then lakes, and eventually became the oceans. It was in these early geothermal springs, only 260 million years after the Earth formed, that controlled chemical reactions began to occur in the benefit of single cells. This was the first life on Earth. After this, it took another billion years for multicellular organisms to develop, and the first multicellular animals came about only around 600 million years ago. How these early life forms were first created is still unknown, and although many theories have been made, there's no definitive answer among them. Because we don't know the exact mechanism through which life first formed on Earth, it's hard to discern if the conditions for life could be present beyond our own planet. But within our very own solar system, Earth might not be the only place with the potential for life, and some of our cosmic neighbors could hold the proper ingredients as well. This video will be the first of a series in which I look at other planets and moons in our solar system to see if they have what it takes to sustain life. And first, I'll be talking about Titan, the largest moon of Saturn and the second largest moon in the solar system. Titan is composed mostly of water, ice, and rock, and is actually larger than the planet Mercury. Because of this, Titan has received a great deal of attention from the scientific community and has been referred to as a planet-like moon. Titan is also the only known moon in our solar system with a dense atmosphere, and in fact, the atmosphere here is more dense than the one found on Earth. In this regard, Titan is more similar to Venus than our own planet. Due to its dense atmosphere, the surface of Titan is shrouded under an opaque layer of clouds and particles, which prevented much from being known about the moon until 2004, when the Cassini-Huygens mission was sent to Saturn to study the planet and its satellites, including Titan. This mission was the first time we got to see Titan up close, and we got images like this back. The Cassini-Huygens mission also allowed us to map the surface of Titan, study the atmosphere here, and even led to the discovery of liquid hydrocarbons on the surface of the moon, making Titan the only celestial body known to man besides the Earth to currently have bodies of liquid on its surface. And this discovery has led many to wonder, is life on Titan possible? Before we get into it, real quick I'd like to define what exactly is meant by life. Although the criteria is hotly debated within the world of biology, most definitions of life tend to include the following characteristics. First, a living organism must be able to maintain homeostasis, or in other words, sustain itself. This is like mammals giving off body heat to keep enzymes in our cells from denaturing, or fish resisting osmosis to keep water inside their cells without letting salt from the ocean get in. Without keeping homeostatic, organisms would not be able to exist outside of the precisely perfect conditions. Second, to be considered living, an organism must be composed of cells. You know, like animals, plants, fungi, archaea, protists, and bacteria all are, and things like rocks and water aren't. Life also requires organisms to have a metabolism, or more simply, organisms must be able to produce energy from certain inputs, using nutrients to build structures like proteins and lipids, and then excrete any waste materials, like how we eat, get energy, and poop, or how plants use sunlight and soil to grow and produce oxygen. To be alive, an organism must also be able to grow, adapt to its environment, respond to stimuli in said environment, and lastly, reproduce. And of course, there are always special cases within biology, like viruses, where this criteria is challenged, but for the most part, these are the qualities we'll be looking for on Titan. When looking for extraterrestrial life, it helps to first understand what allows life to persist on Earth. All life we currently know about requires the presence of liquid water in one way or another, as water serves as the perfect solvent in which chemical reactions can occur. So, when looking for potentially habitable places beyond Earth, most scientists look for signs of liquid water first. Now, Titan is on average nearly 10 times further from the Sun than the Earth is, and as a result, the Moon's average temperature is negative 179.5 degrees Celsius, which, if you're not good with temperatures, is very, very, very cold. So cold, in fact, that this puts the presence of liquid water on the surface of Titan completely out of the question. In fact, much like how the crust of the Earth is composed of solid rock, the crust on Titan is mostly made up of solid ice. However, also in a similar way to how below the crust of the Earth you'll find molten rock in the form of magma, under the crust of Titan is a mantle of molten ice, or liquid water if you want to get technical. This subsurface ocean would most likely be a solution with ammonia, and therefore create an environment where only organisms we'd consider as extremophiles could exist. But these extreme conditions are also reminiscent of those present on Earth when life was just beginning to form. And computer simulations have suggested that chemical reactions similar to the ones undergone by early life on Earth could occur in this mantle ocean. However, energy from the sun would not penetrate through the iced crust, and any organism that inhabited this ocean would need another source of energy to power its metabolism. This would likely force any organisms to surround thermal vents, giving off heat from the moon's warm core. And without equipment on or under the surface of Titan, this type of life would be difficult to detect, and instead we would need to watch for the indirect signs of metabolic processes. This could be done by analyzing the atmosphere of the moon, looking at the methane and nitrogen ratios there for signs of having a biological origin. However, just because all life on Earth requires the availability of liquid water, that doesn't mean all life in the universe would, and liquid water may be entirely unnecessary for the formation of life. Another requirement for life on Earth is the presence of organic compounds which contain carbon. From our probes, we've discovered that the atmosphere of Titan is rich with organic compounds and is chemically active. And while the surface temperatures here may be too cold for liquid water to exist, in its place are lakes and rivers of liquid methane and ethane, which could serve as potential substitutes for liquid water. A process has even been designed in which simple organisms on the surface of Titan could intake atmospheric hydrogen instead of oxygen, metabolize it with acetylene instead of glucose, and as a waste product, excrete methane instead of carbon dioxide. However, water as a solvent is far more efficient than either methane or ethane, meaning reactions can happen at much faster rates, and this would certainly serve as a barrier to the formation of life. But while this methanogenic life is purely theoretical at this time, there is some evidence that points to metabolic activity on the surface of Titan. By measuring the ratios of hydrogen and acetylene in the atmosphere and comparing these to what we'd expect to find on the surface without life, we'd potentially be able to detect if this metabolic process was occurring. Basically, if there was a lower ratio of these compounds than we'd expect to find, it may be the result of an organism's taking them up. And that's just what was found in a study conducted in 2010 at Johns Hopkins University, where researchers found a much lower availability of hydrogen in the lower atmosphere of Titan, and found hydrogen actually disappearing near the surface of the moon. Also found in 2010 were lower levels of acetylene, which is another good sign for the potential of life, since an organism that used acetylene as a means of deriving energy would likely store up large quantities of it, like how animals on Earth store energy in glucose as fat. Of course, there are other possible explanations for these figures, like unknown chemical processes occurring on the surface, or flaws in the data or models used to find these figures. This is what most of the scientific community agreed on as the cause of the measurement, instead of the existence of life on the surface of Titan. But at temperatures this low, a catalyst capable of kicking off reactions is still a notable discovery. And in 2015, the feasibility of such a cell described earlier was given a lot more credit when a research team at the University of Cornell in New York created in a lab a potential cell membrane that could survive and thrive in the extreme conditions found on Titan. The membrane was made from different molecules known to exist on the surface of Titan, containing carbon, nitrogen, and hydrogen. This membrane was named an azotosome, which translates to nitrogen body. In contrast, terrestrial cell membranes typically contain carbon, hydrogen, oxygen, and phosphorus, and are called phospholipids. These azotosomes had a stability and flexibility equal to phospholipids and represent the first substantial evidence that life is at least possible on Titan. Okay, so things look pretty good for Titan right now. So good, in fact, that the Planetary Habitability Index, which is made up of a collection of independent scientists, rated Titan as the #1 most likely place to find life outside of Earth. However, there are still significant challenges to life on Titan as well. First, despite Titan's dense organic atmosphere, one molecule it lacks in any substantial concentration is carbon dioxide, which is a vital source of carbon for most models of life. Like Earth, the atmosphere on Titan consists mostly of nitrogen, but unlike Earth, which also has oxygen, argon, and carbon dioxide, the rest of the atmosphere on Titan is filled with compounds like methane or hydrogen. Without carbon dioxide available in the atmosphere, any organism would find it difficult to obtain sources of carbon without a large initial input of energy, and this would serve as a barrier for the development of life on Titan. Another issue is the surface of the moon itself, which in geological terms is very new and constantly changing, meaning the lakes of methane have not had much time to develop, and we've actually been able to observe features on the surface of Titan changing over the course of just a few years. Many also remain skeptical based on the sole fact that the temperature on Titan is not conducive to chemical reactions, at rates that living organisms require to sustain themselves. While the search for life on Titan continues, most scientists in the field have relegated the moon to more of a test case status for learning how to study other potentially habitable planets or moons, as well as learning what a primordial Earth may have been like. However, in the future, all of this might change. In 5 billion years, which, if you're paying attention, is more time than the Earth has existed, the Sun will begin its process of dying, first by expanding to become a red giant. As this happens, life on Earth will be obliterated, but temperatures on Titan may reach levels to support liquid water on its surface. Furthermore, as ultraviolet rays from the Sun diminish in intensity, the upper atmosphere of Titan will clear up and allow for sunlight to penetrate to its surface. Then, Titan's atmosphere, which is rich in powerful greenhouse gases like methane, would be able to trap more of the Sun's incoming energy and store it within the Moon's surface and atmosphere. These conditions are predicted to eventually last several hundred million years, and if you'll remember, it only took 260 million years for life on Earth to form, so it's thought that life may possibly emerge on the Moon sometime in the future. However, the greater presence of ammonia in the composition of the Moon would greatly delay the formation of life. It's also been suggested that perhaps in 5 billion years, if humans are still around as the Earth is slowly incinerated, Titan could serve as a potential refuge for humanity. But let's be honest, if humans are around for another 5 billion years, we'll have expanded far beyond the reaches of our solar system, and the Earth might be entirely forgotten by then. In conclusion, Titan seems to be one of the most promising places in our solar system to find life. Unfortunately, no real plans exist to visit Titan anytime soon, so it might be a while before we learn the answer to this video. But if you're curious about life on other planets or moons in our solar system, or you just enjoyed this video, please subscribe to this channel, where I'll be going through more potential places for life to exist, as well as many other interesting topics. If you have any ideas on what you'd like for me to make a video about in the future, please let me know in the comments. Thanks for watching this to the end. I'll be back next week to talk about Mars. Thanks.